Okay, let's look at the answers to these questions. This one, pick a point on the wave. Now, I usually go for the crest. It doesn't have to be. I mean, we could pick this point, but just make a similar point on the wave is not here because that's going down as we go left to right. So a similar point would be here, but you could go peak to peak, trough to trough. It doesn't really matter. Um, if we pick those two identical points, we should see that the kind of difference there in the distance between them is, well, that's 2, that's 3, so it is just 1 centimeter. The wavelength of both of those waves, notice that has to be the same. The two waves have to have the same wavelength, otherwise the phase difference will constantly be changing and we can't really then calculate a wavelength. So lambda there is 4 centimeters. Therefore, we have 1 over 4 quarter of a wave of a phase difference. However, we can multiply that by 360 degrees to get that the phase difference is 90 degrees, or we can multiply by 2 pi to get pi over 2 radians. Okay. Next one is more of a real life example, therefore don't be worrying if your answer is slightly different to mine, particularly because the grid doesn't really help that much here. But what we can do is maybe go trough to trough. I would say that's about 133. That's about 167. Therefore, the time difference it is here really would be the time period would be 176 minus 133, which is equal to 34 milliseconds. Meanwhile, the difference between a peak to a peak, or I could go trough to trough. Let's go trough to trough. So between there, that trough and that trough is about 7 milliseconds. So the difference in time between them is 7 milliseconds. So therefore, I don't have to change them to seconds because I'm working on a ratio, really a fraction there. It wouldn't make a difference whether I did or not. But it gives us that it is 7/34 of a wave out of phase. Now I can type that, and we usually wouldn't leave things as fractions, sometimes with radians, but usually not. And that gives me really that it's 0.206 of a wave out of phase. Multiply that by 360 to get it into radians, or sorry, to get it into degrees, which is 74.1 degrees. Do the same thing with 2 pi. And that gives us that it is 1.29 radians out of phase. Okay, you will find you might get different answers, particularly if you go peak to peak compared to trough to trough. That actually varies a little bit along here. Don't worry too much about it. I think that exercise is from the old booklet or old book. But what I'd like you to do is try all the questions on phase difference and the wave equation V equals F lambda. Firstly from the textbooks, which I think Mr. Robinson has already given you, and the question books if you already have them. Okay, so do them and we'll mark through them at the start of the next lesson. Okay.